This conference will now be recorded.
Hello, everyone. Welcome to the Satellite Book Club seminar series. It's a timely talk today with our successful transition of GOES West just yesterday. Today, the topic of our talk is the GOES program operations, the path to 2025. We're glad to have our speaker today is Pam Sullivan, the GOES R and GeoXO system program director. And thanks to William Churchill for agreeing to facilitate. William's with the Forecast Operations branch of WPC, and he's going to guide us through the work with Pam to guide us through the talk today. Just a few routine reminders. As usual, this session is being recorded. We'll take Q&A at the end of the presentation. We encourage you, as always, to post your questions in the chat room, and we're especially interested in hearing from those field staff in the forecast offices, regional headquarters, and centers. Most of you are already doing this. Please always sign in with your full names. It helps us keep track of who's on the call and helps us follow up with you if we have any further information for you. We've learned that some of our emails for this seminar occasionally end up in folks' spam folders. So if you haven't heard from us in a while or otherwise, please check your spam folders. You might find a message from us misfiled there. Always looking for future presenters for future seminars. Please contact the Tower S team. There'll be contact information in the slides ahead. And the training team can help with the development and refinement of training materials for any talk that you might want to give. Brian Mata can provide you with assistance for that. Thank yous go to the folks who pulled this together, the Tower S team, specifically Kashad, GOES-R program, JPSS program, Weather Service Office of the Chief Learning Officer, and our facilitator, William. Many of you know Pam already, but we've got just a few words of introduction for Pam, after which we'll hand the mic to Pam so she can begin her talk. Pam Sullivan oversees the development, acquisition, integration, installation, and acceptance of major elements such as the spacecraft, instruments, launch services, and ground systems for the GOES-R series. Pam joined NOAA in May of 2018. Previously, she managed the GOES-R series flight project for NASA, directing the development of the spacecraft, instruments, and launch services for the 4 satellites in the GOES-R series. And prior to her career at NASA, Pam served as an officer in the U.S. Air Force, training as a space shuttle flight controller and supporting military space experiments using the shuttle. Pam, welcome back to the Satellite Book Club.
Thanks very much, Brian. Very happy to be here again. Should jump right in. Okay, so I'm actually going to talk to you more than 2025, Brian. I've got discussions of the GOES program out to the 2050s, if you can believe that. So, but I'll start with some very near-term stuff, what we've been doing in the last year. I think the last time I talked to the Satellite Book Club, I was talking about getting ready for the GOES-T launch. Well, many of you know, I am sure we got it launched, we got it checked out, and as of yesterday, it's transitioned into operational service. You know, we're all very excited about that, and I've already heard from a lot of users that are very excited about GOES 18 being there as well. The only real technical issue we dealt with GOES 18 was something called the barcode noise, where we looked at that, determined it didn't really was not going to be an operational impediment. And then the noise by itself kind of cleared up a couple months ago. So that's something we're still watching, and we've got some ideas of some improvements to be made if it comes back. But anyway, very happy again to see GOES 18 into operation. And I don't know if there's any space weather enthusiasts on board, but we've actually got a new instrument on GOES 18. The magnetometer is actually a different magnetometer than we've flown on 16 and 17. And that little graph there shows, you know, a line near 0 is good in this case. So we've got much quieter magnetometers on GOES 18 compared to 17 and 16. So our space weather users are also showing their pleasure with that. All right, as part of the handover ceremony where the GOES-R program hands over the satellite to our OSPO friends at Suitland, we actually give them sort of a trinket acknowledgement that they can hang on their wall. And I'm showing this here just because I think our artist did an awesome job with this GOES-T busters. And I probably shouldn't show it for too long before some entertainment lawyers get after us. But anyway, so that's down hanging in Suitland if you find yourself down there. Obviously with 18, where we did the checkout, with 18 being very close to 17, we had the opportunity to get some imagery of 16 on the East Coast and 17 and 18 nearby, and being able to do some comparisons of imagery, as you can see here, where 17 and 18, of course, the image looks practically identical, not exactly in time sequence, but practically identical. And then you can see the pretty radical difference viewing that same location from GOES East. And speaking of 16 and 17, of course, 16's been in operational service for some time. 17 was GOES West until yesterday. It will now be relocated to 105 West, where it'll be in storage mode in case it's needed again. Other things our team has been doing is been working on bringing new kinds of data products into operation. And one of those I'm showing here is actually the GLM flash extent density product, which is expected to be operational in a few months. And this crowd has probably seen all of the next few images I'm going to show, but you know, obviously the big story for the U.S. this summer in terms of weather was Hurricane Ian, massive storm with an incredible amount of lightning, as you can see in this particular loop here, on its first landfall in the U.S. And then a derecho, of course, another thing that we monitor with the imager and the lightning mapper. Again, a massive amount of lightning in this derecho storm, which was one of the billion-dollar disasters. I think I heard just yesterday that the U.S. is now having billion-dollar disasters every 18 days. So this counted as one of them for last year. And of course, fire is another thing that we're watching. This one I thought was interesting, showing the smoke from the fire kind of going in one way, and this very large dust storm, you know, coming from north to south in the same image here. Anyway, so not a great day to be breathing in North Texas there. Another one that I thought was really interesting, there's fires in here, but it's certainly not the thing you see first, you know, with the cloud bank off the coast and then all that morning fog. And when that clears out, you start to see the fires from the smoke from the fires in this one. So I thought this was an interesting collection of phenomena in this particular movie. And another thing I don't see that often, the Saharan air layer dust product, showing you know, sand coming all the way from Africa, crossing the Atlantic, and in this case, landing on somebody's windshield in Florida there. So just another thing that folks use the satellites for. All right, and I've got a few launches to show you. Not our prettiest images, but they certainly represent, you know, significant milestones for some of these programs. So this is JPSS launching from Vandenberg last November. This is a 1 minute meso, so you're only really getting like 3 frames where you can see the heat signature from the rocket taking off there. But anyway, congratulations to our JPSS team for their launch. And this one is NASA's Artemis launch. You probably saw in the news. This is the larger rocket, so you can see a much bigger heat signature there. And this is 30-second cadence imagery, so you're actually getting a lot more steps going across there. But this is the rocket that circled the moon and came back. On subsequent flights, it will actually be the one that takes astronauts out to the moon. And I thought this one was interesting. You can kind of see where the rocket first breaks through the cloud. It seems to open up a hole. I'm not sure if that's really what I'm seeing there. I'd be interested if anybody really kind of understands the phenomenology of that. But anyway, congratulations to the Artemis team. And our last launch, this one in daytime, the other two were at night, but this is actually the Mediasat third generation. So that's EUMETSAT's new generation of their geostationary satellite. And this was a launch from Kourou. So this was actually 3 different launch vehicles, 3 different satellites, 3 different launch locations, all of them caught by GOES-R satellites. So anyway, so MTG, I'm sure this audience will actually be interested in seeing that data when it's ready. This is, they're going to have an ABI class imager and a lightning mapper that will be stationed over Europe and actually have some overlap of the Atlantic and some of the Western Hemisphere. All right, and then from a GOES-R perspective, we've got 1 satellite left to go. That's GOES-U. You can see a picture of it there in thermal back. It is marching along. This satellite we're going to launch on a Falcon. That's the first time we've done that with these series. So we've got some sort of new things to process as far as how we integrate and the mission design with the Falcon. But that's all on track, aiming for a launch next year. Now that we're in 2023, I can say next year, so not that far away. And I will let you know, this has not been decided, but there are discussions about whether or not GOES-U will go immediately into service, possibly replacing GOES-16. And the main driver for that is that we're going to have a new instrument on GOES-U called the compact coronagraph that looks at solar coronal mass ejections. And so that's an instrument that space weather folks are really interested in seeing in operation as soon as possible. So there's, like I said, not official. There's some questions to be answered, but I won't be surprised if that's what ends up being the plan ultimately. All right, and a graphic here, just for reference for folks, but I thought it was, you know, a really nice graphic that shows all the way back to the first GOES-1 in 1975, where the bars represent the time that each of the satellites were operational. And you can see the 5 series of GOES that we've had so far. And I really want to give a shout out to Tim Schmidt, who really helped with the archaeology of figuring out the exact dates of what the satellites were doing. Anyway, so it's a nice graphic to have as we're coming up on really the 50th anniversary of the geostationary weather satellites. All right, and GeoXO. I know this audience is really operationally focused and maybe hard to get excited about things that are a decade away. But this is where I've been spending a lot of my time, is planning the next generation system that will come after GOES-R, and you know, that will be the operational system hopefully in about a decade. Anyway, in the last month, we passed a major milestone, milestone 2, which sounds like a bureaucratic hurdle, but it is. But it was really important because it was the step where we baseline our requirements, the cost of the program, and our schedule. And it also gives us the approval to proceed with the major acquisitions, so the instruments and the spacecraft. So that was a very big deal for us. And the constellation that we're planning on building is shown there. In GeoXO, there will actually be 3 operational satellites. So in addition to the east and west satellite, we're also going to have a center satellite. Our east and west satellites for GeoXO will continue to have the imager, the lightning mapper, and then they'll be joined by an ocean color instrument, something for our ocean service and our fishery service friends. And then we'll have that 3rd center satellite will actually have a different set of payloads. That's where we'll have our infrared sounder as well as our atmospheric composition instrument. And we're well underway. We've got studies ongoing now with industry, looking at the instruments in the spacecraft, and we're coming up on a couple major milestones as well. The announcement of who's going to build the imager is expected to come this month. And just another way to kind of look at what we're planning for GeoXO. The first column is the continuity of things that we're doing. So the imager, the lightning mapper, the DCS platform signal relay, we're planning to continue. Also DCS commanding is something we're planning to continue. We were debating not doing that, but our USGS and Army Corps of Engineer users were very vocal about their desire for that capability. And so that stays in the system. And then we're going to have the rebroadcast services. We will have the equivalent of HRIT, MWIN, and GRB. Although those won't be relayed on our satellites, we're going to use a commercial service for that. The middle column shows the enhancements that we're planning for weather hydrological services. That, of course, is the hyperspectral sounder, the potential addition of a day-night imager. We will be making both spatial and spectral resolution improvements for our imager, potentially some spatial resolution improvements for the lightning mapper, and we have doubled the number of channels for our DCS. And then the last column, of course, the enhancements for oceans, coast, and climate include the ocean color instrument and the atmospheric composition instrument. And the photo there is a picture of something called TEMPO. That's a NASA research mission that is an atmospheric composition instrument. It's actually launching in a couple of months, and it will be the precursor. It will look a lot like, the data from that will look a lot like the data from our ACX instrument. And so users will get, I think, a good preview of what GeoXO is going to look like, and have the opportunity to use the data and tune their models to use that data. So, all right, I've got one slide on each of the instruments, and this just compares ABI to what we're planning for the GeoXO imager. The main thing I think people are going to notice is just the resolution improvements. For the visible red channel, we're actually going down to 1/4 kilometer. The other visible channel, and then the veggie channel that we use for the green equivalent, those are going down to 1/2 kilometer. And then several of the infrared channels are going from 2 kilometer resolution down to 1 kilometer. So that includes the fire channel, one of the water vapors, and then the long wave window as well. So that will be a big difference in terms of resolution and also data volumes. Another thing that we're planning on adding on GeoXO is 2 new channels. Both are aimed at measurements of lower level water vapor. So one at 0.9 microns, and then another one at 5.1 microns. So some modest improvements, I would say, in the imager. The lightning mapper, I know this just looks like spaghetti, but if you can see the blue dashed lines are the fields of view that our current lightning mappers carry. The purple is the potential of what we may see with the lightning mapper on GeoXO. And that weird sort of saddlebag shape is because the instrument design is going to go from, maybe, depends who we pick, but may go from a single optical channel to one with 4 telescopes. So you get that kind of splaying out of the field of view. And so obviously you get more coverage. And then some of the contractors that are studying this are actually going to have improved resolution down to 4 to 6 kilometers. So again, it depends who we pick, but some potential improvements for the lightning mapper as well. So the sounder, obviously a big improvement for NWP, but also for local nowcasting. It will have the capability to do pretty much a full disk image, as well as CONUS and mesoscale type scans. 4 kilometer resolution is planned. The spectral coverage is shown. The bright blue bars are what we're planning for GeoXO, and that's in comparison. The orange is the European sounder, and then the green is the CRIS LEO sounder that we currently have. So you can see a little bit different spectral coverage there. And of course, hyperspectral. So, hundreds of channels are planned for this instrument. All right, moving a little away from some of the weather stuff, the ocean color instrument, really high resolution, 300 meter pixels here. The scan pattern is not going to be like the imager or the sounder where it wants to see everything. It's really going to be focused on those bright blue areas on the map. So really it's going to be looking at the coastal areas around the US, the Great Lakes, and we're planning to do coverage of those areas every 3 hours. Those scientists really want it as fast as they could get it. So we're studying maybe down to every 2 hour coverage. again, depends on some of the design choices in the studies that we're doing right now. This is also a hyperspectral instrument over VIS into the near IR. And in this instrument, we're also looking at the possibility of putting a night band channel in there. So not decided for sure, but that study is underway. And our last instrument, let's talk about the atmosphere composition instrument, another hyperspectral instrument, this time in the UV and the VIS, 5 kilometer pixels at nadir. And this one is going to be doing hourly scans of the CONUS, as well as a fair bit of Canada and Mexico. And of course, this is looking at chemical species that affect air quality over the US. All right, and this one, again, our artists are been hard at work helping us. And this is really a sales pitch, sort of describing the different kinds of things that GeoXO is going to be doing. But I think it's impressive because it's actually real. This is like a typical day. This is not an unusual day in the life of GeoXO. Every day we expect GeoXO to be doing the monitoring of the air pollution, fires, severe storms, hurricanes with the ocean color, of course, looking at harmful algal blooms and helping with fisheries, and then doing sort of the special things that are needed for periodic things like volcanoes or maybe industrial accidents as well. So data distribution. Cloud is going to figure prominently in our plans for GeoXO. We actually think most of our users are going to be either accessing the data in the cloud or retrieving it from the cloud. And so that's really envisioned as our primary data distribution. However, we know there are users that want RF signals. So we are going to, again, have RF equivalents of MWin, HRIT, GRB, so that folks can receive those. Our plans for those are still being formulated. We are planning to work with our user community to define those services and do some pilots, to convince people that these commercial services will actually meet their needs as well. And the schedule, I won't go into this too much. Let me just say that we are less than 10 years from launch, and that is really scary. We've got a lot of work to do before that first launch in 2032. And the last thing I'll share with you is our snazzy new logo. The top one, I really like the X there. Has it features some of the new observations, some of the current and the new observations that we plan, and you'll start to see this logo in, of course, GeoXO program material. So anyway, so thanks very much. Looking forward to talking to folks about questions.
Excellent. Thanks, Pam, for that excellent presentation. So I want to encourage everyone to stick around. We're going to do some Q&A. I just want to give a couple reminders about the SBC first. So the SBC will not meet next week for January 12th due to the AMS conference in Denver. So just a heads up for everybody on that. And our next session will be on the 19th of January, where our own at WPC and OPC, Javier Vilice Bravo, our satellite liaison, will be presenting that week. So that'll be January 19th. And then also just want to remind you that you can contact the Towers team with Leave Burley and Kashad Bowman. You can direct questions toward them about the SBF, or the SBC. And also for configuration of satellite products at your local offices. They're very helpful when it comes to that stuff. So be sure to reach out. And then lastly, we'll be posting a link where you can share any feedback you have on this session for the SBC. So be sure to check that out as well after the fact. But you can go ahead and send your questions in through the GoToMeeting chat, and we'll go through some of them here with Pam. So Pam, we'll start with from Scott Lindstrom. He's stating that there are many satellites in storage now. We've got GOES 14, 15, 17, and when GOES-U is launched, another will be stored. So he's wondering if there's infrastructure to exploit these instruments from these stored satellites in field experiments, for example, in addition to running the operational GOES East and West. So are we simply running out of storage space, or
Yeah, let's see, I don't have a definitive answer for that. I know we've occasionally collected ideas for what we could do with satellites that are in storage. There is a downside in that every satellite that you're operating, you got to process the data for, we run out of strings of the ground system. And so if we use one of the strings for a spare satellite, there's a risk to an operational satellite, because if you need to fail over from operational to a backup, then the backup string is doing something else. So haven't been a lot of detailed plans about using the backup satellites that way, but I do hear interest from this, and like I said, occasionally it's discussed. So I would say we probably need to maybe get some definitive ideas and maybe plan periodically. Some things can happen. It's probably worth doing that in a more structured way.
Is some of that base infrastructure normally upgraded with the new generation of new satellites? So for GeoXO, would those strings be increased? Or
we're actually planning on using the GOES-R ground system for GeoXO. We'll be adding a string because we've got the third satellite now. Yeah, we really sized, the GOES-R satellite system, assuming there'd be 2 operational satellites. We'll add some stuff for GeoXO, assuming there'll be 3 operational satellites. And so, like I said, there's not a lot of extra processing capability left over. The other thing to mention with the leftover GOES-N satellites, the GOES-13 has been given to the Space Force, and that one is coming near its end of life. So I forget exactly which one, but 14 or 15 is actually going to be given to Space Force as well. So that's going to be operating where they operated over the Indian Ocean. Okay.
Excellent. So a question from, looks like Jason. Any indications as to what the temporal resolutions for the GeoXO sounder sectors will be? We talked about the spatial. Was there information about the temporal?
It's being sized so that it can do a full disk scan in an hour. So that same scan rate could be applied to conuses or mesos, but subtracting from the conus rate. So if you can imagine, you could do like half a conus and then spend 15 minutes doing probably 3 conus or something like that. So that scan pattern definition hasn't been defined. So that's another thing we'll definitely be looking to users to see how do you want to do that, the same way that we've done with ABI and the couple of scan patterns that it has. So.
Okay. And Jason also asks, will GOES-17 simply be shut down, or are there plans to use the extra imager for experimentation while storage? So you talked about that a little bit.
Kind of the same answer. Not any direct plans. Particularly with 17, I think with the loop pipe issue, I think folks are thinking, or probably hoping they don't have to use it again.
Yeah. So. Carl Ryan then asks, what kind of lead time will end users have for the transition with GeoXO to commercial rebroadcast of HRIT, EMWIN, GRB? And will it be similar to GOES-R and L-band, or something different like KU?
Yeah, with the first GeoXO launch in 32, that's when we would plan to have that first commercial equivalent flowing. Obviously, we're not stopping the GOES-R pieces of that, but if the GeoXO satellite, goes into operation immediately, it would be as early as 32 that we would have the commercial equivalent for that. The L-band, I don't think can be used by commercial services, so I think it is more likely to be C-band or KU, something that is a normal commercial broadcast.
Okay.
And I should add the GeoNetcast. Folks might be familiar with that. I think that's a C-band broadcast. So there's some experience with using commercial broadcasts. It's not completely new territory.
Okay. All right. And from Steve Corfidi, he asks if you can expound a bit on the planned improvement to the nighttime resolution.
Yeah, the day-night band. So this is, folks I'm sure are aware of, the VIIRS has that channel, and so we're looking at the equivalent kind of capability, something that can look at reflected, moonlight band imagery. And we're studying, again, this is just being studied. We haven't committed to this yet, but we're studying having that capability in our ocean color instrument, and the day-night band resolution that we're looking at is 500 meters for that. So somebody, I'm pretty sure that's right. Somebody will correct me if I'm wrong.
Awesome. I have a question for you, which is just what would be your favorite, or what are you most excited about with GeoXO in terms of the instrumentation?
I've been really excited that we're picking up a whole bunch of new users. It's like we're kind of used to the weather service, sort of the immediate weather, stuff that the imager and the lightning mapper do. But with the sounder, right, we get more into the modeling. So there's like a whole new science and user set that we need to be aware of within weather service. And then of course with the ocean instrument, there's ocean service and fisheries, which I know nothing about. And so just learning the applications of the ocean color data is something I'm excited about. And again, building our user base, and then the atmospheric composition users, our weather service, but also the OAR folks are kind of the main ones that work with the Environmental Protection Agency that actually does the weather forecasts, like the air quality thing that shows up on your phone. And so we'll be, again, learning that customer base in order to feed into that model. So I'm really excited about expanding the observing capabilities and the user set. Another thing that I'm actually really excited about, and probably won't wait until the GeoXO launch, but the cloud delivery. Again, I think it really allows us to expand our user base. To get the GOES-R data right now in real time, you really have to be a government organization or a school, right? You need to have, those very large pipes or satellite dish or something like that. But with all of the data available in the cloud, I think a lot more people are going to have access to the data. And what happens then? When a lot of people get the data, they do things you never even thought about. And so I think the cloud is actually going to enable not just more users, but more applications. And so hopefully bringing more value for the investment that we're making.
Yeah, definitely. One other question I have too is, I think it's really interesting that there's going to be the 3 satellite configuration. So the hyperspectral sounder will only be on the central one, you were saying. So would the plan be, or would you expect anyway, that that's going to be the first one planned to launch to get that instrument?
No, not our first plan. Our first plan will be the imager. The continuity of the imager is critical, and so just looking at the the probable end of life for 16, 17, 18, and 19, all of that says we really want to have the imager up first. So the sounder, unfortunately, right now is not planned to launch until 35. So sounder fans have a little bit longer to wait.
All right. And it's like we got a couple more questions come in from Mike asking, how does your job change with the latest NESDIS reorg?
Not much. The GOES-R office goes to the Office of Geo Observations. As near as I can tell, everything else stays the same. So we'll probably have a lot of org charts and document templates that we need to change. But other than that, GOES-R stays GOES-R, GeoXO stays GeoXO, and so the Geo office is really going to continue to manage those 2 major programs. I think the reorg is probably more meaningful for some of the other organizations where people are kind of moving from one office to another. But for us, it's really just sort of rebranding.
Gotcha. And then from Scott Lindstrom, we have, you probably showed this, but is the ocean color instrument slated in the central position? Notice that your shoreline graphic did not include American Samoa, and wondering if that's outside the field of view.
So yes to that last answer, but even that, we're going to have 2 ocean color instruments. It'll be on the east and the west, and so that graphic that I show actually is the combined viewing area for both the east and the west ocean color instrument.
Okay. Do we have any last questions before we wrap up here? Let's see, from Jessica Levine. Any thoughts about GOES becoming one, smaller, quicker missions with less instruments in the future instead of large and expensive payloads, and two, serving as relay satellites instead of something like TDRS?
Yeah, good question. We, as part of the GeoXO formulation, we actually went through that study looking at, does it make sense to break it up? And the answer was no. A little bit surprising. You hear a lot about the new space and the mini satellites and the microsatellites, and but those capabilities are not really breaking into geostationary orbit yet. To get to geo, you still need a really big satellite, a significant propulsion system, a significant attitude control system. So that new space kind of architecture is not really it's not really making the dollar cut basically for geostationary orbit. So it's really, the architecture decisions are really still, you pay a lot to get to geo, you might as well put everything that you want on the same satellite, because you're paying for a large rocket in any case. Where you will see that kind of change, I think, is in the new LEO architectures. And you guys should really ask Tim Walsh to come visit you guys and talk about what their future plans are as well. I think there's a lot more interesting, frankly, a lot more variations that they're looking at, a lot more interesting architecture trade space that LEO is doing.
Okay. Well, I think that'll about wrap up your question section then. Want to thank Pam again for the excellent presentation and questions, and I'll throw it back to Brian to wrap things up.
A terrific presentation, William. Thanks so much for coming to facilitate, and Pam, a very timely brief after yesterday's transition. Look at what just happened and what's ahead. Probably my 11th GOES transition, either on the NESDA side or the Weather Service side, and it couldn't have been much smoother, really. In particular, given the expedited, compressed transition to operations, 10 months of work, really what would normally take, 12 to 16 months, I think. So now the Western users can benefit from the improved performance of the GOES 18 ABI, and SWIFC, of course, thrilled with the magnetometers you said. So thanks to everyone who made that happen. As William mentioned, our next SBC will be in 2 weeks because of the AMS meeting next week. So please join us in 2 weeks for Javier's talk, and we'll resume the Satellite Book Club seminar series then. We thank you for joining, everyone, and have a great day. Signing off.